All right, so again, objects A and B are heading the same direction after they collide. So the momentum before for A and the momentum for B, right? We don't have numbers. It's not a quantity necessarily, but it is measurable because it gives us those lines. Which momentum would belong to object B? So remember, the momentum before has to equal the momentum after. Okay, so before A has 1, 2, 3 parts to it. And B has just the 1. To make a total of 4. Afterwards, A has 1, 2. So our answer has to be 4 to get that other 1, 2 to make 4. Does that make sense?
Did you draw this window?
Mm-hmm.
That's pretty good.
Yeah, my car didn't come out quite as well. You should see my hippo though. Hippo's much better than my rhino. But yes, but no one ever believes me when I say how aggressive hippos are, and I just didn't want to have that argument today.
Hippos are like scary animals.
Someone
like
told
a dragon face, but with like a horn on it.
Huh?
A dragon?
Your
The
rhino
Komodo
looks,
dragon?
yeah, it looks like, look at the face of it. Is that not like a Disney dragon right there?
no, it looks like a dog.
Looks like a bull sort of.
I'm just saying I'm gonna put in for the art teacher's job. I think I'm qualified. Don't crush my drink. Thank you.
Then I can have your job.
There you go.
I can be
Some days I
teacher.
teach. Yeah, some days I teach physics. All right, so a rhino hits a small acacia tree, which is a tree in Africa. Cool.
We got those trees in Minecraft.
Okay. And we know that impulse is equal to the force times the time, which is also equal to mass times the change in velocity. Right? And we talked about this the other day, how you only have to use 2 portions of it. You don't use all 3 ever. Okay, but talking about this rhino and this tree. The force, is it going to be the same or different force? Does the rhino hit the tree with more force than the tree hits the rhino, or?
Well, I'm guessing the tree's stationary, right?
Sure.
It's not?
I didn't say that. So, okay, but forces.
Yeah.
Rhino hits tree, tree hits rhino. Are they the same force, or are they different? Same. Equal and opposite. Newton's third law. All right. Does the time of the collision happen the same for both objects? Yes. So, if the force is the same and the time's the same, the impulse, therefore, must be the same. Now, here's where we get into some issues. Is the mass the same?
No.
Probably not. It's probably going to be different. And therefore, that change in velocity is probably going to be different too. And it's going to depend on those values. To put this in another way, we have a bug and a car. So there's the bug. And they collide. And again, impulse equals force times time, which is equal to mass times change in velocity. Is the force the same or different? Has to be the same. Newton's third law says equal and opposite forces.
So I'm guessing the time would be the same too.
Time's always going to be the same. You do not experience time any differently than anything else that we're aware of. So if the force is the same and the time is the same, the impulse has to be the same. All right. Now we know 100% that a car and a bug have a different mass, right?
Yeah.
All right. Which one has a bigger mass?
Car.
Car. So
Is that your M?
That's an M. So what we're going to say is that the car has a much bigger mass than the bug does, right? But the mass and the change in velocity have to equal each other because they're equal in this equation. So what you're going to see is a very small to almost non-existent change in velocity for the car. And a much bigger change in velocity for that bug. So while those values are going to equal the same when they're multiplied together, the individual parts are not necessarily the same.
Yeah, that's weird.
All right, so last one. I left off the mass, so we're going to say a ping pong of mass 0.02 kg. It's dropped off a 4-meter table going 2.3 meters per second. It bounces up at 1.7 meters per second after an impact that lasted 0.07 seconds. The first thing it wants from you is the delta V. So remember, delta V is equal to the final velocity minus the initial. So it'd be 1.7 minus negative 2.3. Because remember, it was going down. Down is negative. When you have two negatives together, they become, or negative with a subtraction, that becomes a positive. And so that should equal 4. Someone check me on that.
4, yep.
Awesome. All right, so my change in velocity is 4. Now what's my impulse? So I'm going to do J equals mass times my change in velocity, which is 0.02, times 4 is going to give me what? Should give me 0.08, right?
Yep.
Okay. And impulse is in Newton seconds. So then we're looking at force. So force times time is equal to that impulse. So force times 0.07 is equal to 0.08. My force is what? So what is 0.08 divided by 0.07? 1.14? Any questions?